Hello, and welcome all to this session. My name is Andrea Manara from the ITU, the International Telecommunication Union. It is an honor for me to introduce the second of five final events for the second edition of the ITU GeoAI Challenge. Yesterday, we had a very interesting session on the air pollution competition with three high-quality presentations from selected competitors. I'm sure that also this afternoon we'll have a super interesting session. The ITU GeoAI Challenge aims to provide a platform for collaboratively addressing real-world geospatial problems by applying artificial intelligence, machine learning to advance the United Nations Sustainable Development Goals. Participation is open to any individual from any one of the 193 member states of the ITU. ITU also provides state-of-the-art, free-of-charge platform to participants of the challenge who do not have adequate computing resources in their respective institutions. Today's session deals with the Cropland mapping competition. We had 330 participants enrolled, and 74 active participants submit a solution via the 3D platform. The goal of the Cropland mapping with the satellite imagery problem statement is to encourage the development of accurate, cost-effective classification model for cropland extent mapping in selected regions using machine learning and artificial intelligence techniques. This challenge has been curated by the United Nations Food and Agriculture Organization, FAO, the United Nations Office of Drug and Crime, UNOG, in the framework of the GeoAI working group of the UN OpenJS initiative. Special thanks to the UNODC for the contribution of 3,000 francs to reward outstanding competitors, ending up to the 1,000 francs that ITU allocates for each GeoAI competition. These allowed us to invite 5 teams for this final event. Each team will showcase its solution and will be awarded during this session as a recognition for their outstanding performances. And now it is my pleasure to introduce the host of this problem statement. Lorenzo Vita, if you can just show your video. Lorenzo is a geospatial information officer for the illicit crop monitoring program at the research and trend analysis branch of University of Vienna. And he has been actively involved in designing and implementing technical assistance programs for development of national illicit crop monitoring systems. I will also call Pengyu Hao, who is a consultant at FAO. His research focuses on agricultural remote sensing applications, including agricultural land cover mapping and crop growth monitoring. In addition, he's responsible for managing the remote sensing platform at FAO. I will also call Maria Brovelli, which amongst other responsibilities, she is also the co-chair of the UN Open GIS Network. She is a professor of GIS and the Copernicus Green Revolution for Sustainable Development at Politecnico di Milano, and member of the school alla Sapienza. And she is also the chair of the UNGGIM Academic Network and curator of the Geospatial Series at the We also have another representative from UNODC, Wen Lu. She will also assist. I will now give the floor to Maria for a brief introductory remarks on the Open UNGS initiatives, and then she will give the floor to Lorenzo and thank you for the introductory remarks on the competition. We will then proceed to 10-minute presentations from each of the 5 selected competitors, followed by the award ceremony. As you see, we have a very intensive program for the session, so let's begin. Maria, the floor is yours.
Okay, thank you, Andrea, for this nice introduction. And good day, everyone. I don't want to steal too much time. I want only to briefly introduce the UN OpenGIS initiative. That is an initiative started in 2016 with the idea of providing an open platform for UN and also possibly to reuse this open platform also for developing countries. Within this initiative, a couple of years ago, we decided to start a new working group because the initiative is organized by working groups. And this new working group is a working group related to GeoAI, where many agencies of UN are contributing, like for instance the ITU. You saw here Andrea and other colleagues who are contributing, and also you saw FAO, you saw UNODC. So the main aim of UN OpenGIS is to share our experience with respect to the open solutions that we can provide, and in this specific working group to work on geospatial AI. So if you are interested in this initiative, being an open initiative to everyone, please contact us, so contact me or contact Andrea in such a way that we can give you more pieces of information about our activities. And this challenge is one of the activity of the UN OpenGIS. Okay, thank you for giving me the possibility of explaining what UN OpenGIS is, and now I leave the floor to Penchu and Lorenzo.
Okay, I will start my presentation about the summary of this challenge, and I'm now sharing my screen. Okay, this challenge is the ITU GeoAI challenge for the cropland mapping. And now what we have is the final presentation and the prize stage. The challenge is funded by UN OpenGIS Initiative and run by ITU platform and proposed by FAO and UNODC. Here is a brief introduction about the topic and the objective of this challenge. Basically, there are more and more remote sensing data available at global scale. And the basic usage of the satellite data at agricultural applications is cropland accent mapping. And currently, there are already several global level cropland accent products, but all these products have large disagreement. So this come to the scientific question that how can we have accurate cropland accent maps at global level? So I think we think the AI is a new technology that can help a lot on cropland mapping. So the topic of this challenge is to use AI to map cropland extent. In this year's challenge, we have 2 parts. The first part is to use the 1 year round remote sensing data time series to identify the cropland for the annual scale. And the second part is to using 1 month data to identify the temporal cropland in the May of the year 2023. So for the first part, so there are 2 test regions which are located in Sudan and Iran. The remote sensing time series data is provided, and the participants have tried to using the training samples and satellite data site to identify the yearly cropland. For the second part, the test region is in Afghanistan. The remote sensing data of that time period is also provided. For both parts, the scripts of all the solutions will be open to public. This is the purpose of the Open GIS initiative. During the past year in this challenge, there are in total 71 groups have submitted their solutions. And among them, based on the automatic validation system in the platform, we have selected the top 20 groups in the second round based on their classification accuracies. And in the second round, we have asked all the participants in this round to submit their technical report. And based on all these technical reports, we have selected the top 8 teams for a presentation stage. And after the top 8 groups in the presentation stage, we selected the top 5 teams based on all the performance, including the script, the technical report, and their first time presentations. And here are the top 5 teams we have selected for this final stage. And now all these teams will have their presentations for their challenge. And now the floor is for all these teams, and good luck. Thank you all, and good luck for your presentation today. Thank you. Floor are yours.
So I think it's my turn first. So I will share my screen. Hello, everyone. Okay, I think my screen is shared. So let's get started. I'm Antoine Saget. I'm a French PhD student in machine learning at University of Strasbourg. I'm in my 3rd year on a PhD relating to machine learning and with application to remote sensing. So let's get started with the challenge. So I think Penyu did a good job to summarize the challenge, so I will not go over it in details, but we have a binary classification problem where each data point is either a crop area or a non-crop area. And we have 3 countries, and for each country, 500 training samples and 500 test samples. And of course, the goal here is to build a model that generalizes well on unseen data. And in this case, the unseen data are the 500 testing samples per country. So now about the solution, my focus here was simplicity. So there are 3 simple steps. The first one is gathering Sentinel-2 time series from Google Earth Engine. The second step is data preprocessing, which mostly consists of interpolation and resampling. And finally, training the model, which in the case of my solution is 1 random forest model per country. So now let's go into a bit more detail. First on the data gathering. So I went for Sentinel-2 time series because we have tasks that is related to vegetation. So of course, not all vegetation is cropland. For example, forests are vegetation, that is not cropland. But I think that most of the tasks relate to distinguishing between what is vegetation and what is not. And of course, vegetation will grow throughout the year, while things like cities don't move as much. So time series are really well suited for this task. And so from now, my goal is to gather as much data from the Sentinel-2 satellites. And the Sentinel-2 satellite revisit time is 5 days, but sometimes it's less than 5 days. And sometimes there are missing time steps. And of course, depending on the location on the globe, the image don't arrive the same days. So what you end up with is time series that are not aligned and that are of different lengths. And of course, this will be a problem for our model because they don't handle the data in this format. So we will have to deal with this problem later. But first, a bit more on the data gathering regarding the Google Earth Engine request. I did not do any cloud filtering. In fact, I tried, but it didn't improve my results. Maybe because I was too aggressive in the filtering, maybe because I didn't do it properly. I'm not sure. Maybe more experienced researcher can improve on that, but I didn't. Also, so I gather all the data from Sentinel-2, and the only thing I add is NDVI band, and because again, we are in a vegetation-related task, so a vegetation index seems like a good idea. And one final note regarding the data gathering. If you ever want to reproduce the result, please be careful in the design of the Google Earth Engine request, because there is a very easy mistake you can make where you only ask for matching time steps. And as I said earlier, most of the data is mismatched. So you will lose most of the data if you are not careful in this step. But now, let's say we've gathered the data, we are in the pre-processing step. And to solve the alignment and the size problem, what I do first is interpolation. So I basically fill in all the missing time steps by interpolating between the existing time steps. So here we have 0 and 10, and we interpolate in between to have 0, 2, 4, 6, 8, 10, and so on. And this will basically solve both of our problem. We end up with time series of same length and that are aligned. But the problem now is that most of the data come from the interpolation, so most of the data is redundant. So the next step is simply resampling to go back down to a similar quantity of data that we had with Sentinel-2. But this time, everything is aligned and everything is the same size. And that's basically it for the data pre-processing, nothing more. And that's because of the model I use, which is random forest. And random forests are known to be quite robust. You don't need to normalize the data. You don't need to care about correlated feature. And they are quite robust to outliers. And of course, random forests are fast, easy to implement, easy to use, and they are quite common in remote sensing as well. So for all those reasons, I went for random forest. So one random forest per country. Next, regarding hyperparameter tuning, I didn't tune the parameter of the model. However, I tuned the time series length. So I started with a few months to a few years. And I also optimized the position in time of this time series. And I found that the optimal time series length is between 1 to 2 years. And the optimal time series position is basically centered around the target date. So a few months in the past and a few months in the future. And we will talk a bit more about that later. But now for the results. So first, a quick summary of the results. So we can see here the cross-validation accuracy by country, and we can already see that Afghanistan's accuracy is lower. We will talk about this more later. But yeah, the average cross-validation accuracy is 93%, and the private leaderboard accuracy is 94%. Now for a bit more interesting results. I wanted to see how the model would behave if we don't have access to the future data I talked about earlier. So basically what happens if we are in a real-time prediction scenario. And we can see here that the prediction accuracy dropped a little bit, but not much. So here the conclusion is that the approach, the solution I went for is still valid in a real-time scenario. Then I looked at the radiometric bands. So on the first line is all the bands, the Sentinel-2 band I used from for the challenge submission. So there is like RGB, infrared, NDVI, and so on. And on the next line is NDVI only. And we can see that we almost have the same accuracy, again, a small drop in accuracy, but very small. But the time is significantly lower with NDVI, and the memory footprint is also much lower. So it's up to the user to see what trade-offs they want to go for in their situation. Next, a quick note on scaling. So here on the left, I don't talk here about data downloading time or data pre-processing time. I'm talking only about training and inference time, and using the provided data set of a total of 3,000 data points. The training is very fast and the inference is almost instant. And then I scaled up the dataset to 1 million data points in training and 1 million for testing. And we can see that inference is still very fast and training start to go a bit slower. But if you ever have 1 million datasets in training, you can go for a GPU implementation and get almost like a 30 times speed up. So it's basically a non-issue either. So that's it for the results. Let's summarize the strengths and weaknesses of the solution. So as I said already, the model is simple, fast, and easy to train. It can scale very well. It's robust to unclean data, and it's up to the user to adjust the model to their need in terms of accuracy, speed, and memory footprint. For the weaknesses of the solution, the simple pre-processing I did works well for random forest, but might not work well for other models. So it's not very plug and play.
1 minute.
Yeah, almost done. The download and data interpolation step are quite slow compared to the rest. So they might need some optimization here. And as I said, there is a slight decrease in accuracy when you don't have access to future data. Finally, for Afghanistan, the accuracy is lower. This might be explained simply because the shorter time span makes the classification task harder by itself, because you basically ask a more precise question, and time series might be less appropriate in this case because of the shorter time span. Finally, a very quick conclusion. High accuracy is achieved with a simple model and simple pre-processing. For my solution, I don't think much improvement can be made with the model itself, nor the pre-processing. Maybe cloud filtering, but I'm not sure. I think the current bottleneck is in the data set, so basically just making it larger will certainly be better. But as we said last time, I think Lorenzo pointed it out, that there might be a semantic scale mismatch with the data, with the resolution at which the data has been labeled and the resolution of the Sentinel-2 image. And to solve this problem would require higher resolution data. So that's it for me. Thank you for listening.
So thank you, Antoine. Thank you. Very nice presentation. Congratulations for your work. And then Pengju, do you want to introduce the next one?
Yeah, Adrian, I think is the next one, correct?
Yes,
Okay.
Adrian, yes.
Okay, I'm going to share you my presentation. Do you see my presentation?
We do.
Yes, yes.
Okay. Well, I am Adrian Carl, and I'm going to show you my solution for the Cropland mapping challenge. First, let's introduce myself. I am from Uruguay. I am an agronomist. I have a master's degree from data science, and I work as a researcher in the National Agricultural Research Institute of Uruguay. Well, as all we know, the objective of this challenge was to develop a machine learning model for mapping annual crops in Afghanistan, Iran, and Sudan. For that, the available growth data consists of 1,000 points for each country, half of deployment for testing and the other half for training. The training data consists of half of the point of annual crop and the other half of non-annual crop. In the case of Iran and Sudan, the data were extracted for the year 2019, and in the case of Afghanistan for the year 2022. In my case, for this challenge, I decided to work with Sentinel-2 images that are free access images. I obtained and processed the images on the Google Earth Engine platform. That is a free access platform that everyone with a Gmail account can use it. Sentinel-2 is a satellite that the images has a total number of postal bands that measure different portions or channels of the electromagnetic spectrum, like blue, green, red, near infrared, red edge, and also has another extra bands like the SCL band, that is a quality band that classifies each pixel according with a value from 1 to 11, for example, vegetation, soil, water, their areas, high probability of presence of cloud. Well, the first step that I did was to convert the ground data that was in CSV file format to shapefile format using Pushy software, that is a free and open source software. Then I uploaded the shapefile to Google Earth Engine platform. In Google Earth Engine, the first thing that I did was to decide which period I'm going to extract the image satellite information. In the case of Iran and Sudan, I decided to work from July 2019 to July 2020. And in the case of Afghanistan, from July 2022 to July 2023. And also did image filtering using the SCL band. In this band, I defined that good pixel for me, good quality pixel, a pixel with value 4 to 7 is a vegetation, soil, water, or with a low probability for presence of cloud, and any other value are bad quality pixel. In this image, you can see in the left a raw image with the presence of clouds and cloud shadow, and after applying the image filtering, you can see that the image keep the good quality pixel and excluded the bad quality pixels. And a consequence of that is that in the image you have gap. The next step was to the image that I obtained from Weather Engine was to calculate 6 spectral indices, BAT1, IRESI, MBR2, NDVI, and so on. A spectral index is obtained by combining 2 or more spectral bands. Doing that, I harness the information from 500 to 2000 nanometers of the electromagnetic spectrum. After that, the next step was to generate synthetic image. Why I did that? Well, for each year, so the dates that are obtained, the date where the image are obtained for Sentinel-2 are different. And also because after applying the filtering, I have gap in the images, I decided to generate synthetic image for 10-day period to generate for identical periods independently of the year. To generate a synthetic image, the process is to take, for each pixel, to take the highest values of all the images that fall into a corresponding period. In that way, generating 10 days synthetic image for a year, you're going to have 36 images. And independently of the year, the start date and end date for each image is going to be the same independently of the year. Well, because I work with the 6 indices, doing that, I obtain 6 stacked images, 6 images stacked, and each stack has 36 synthetic images. After that, the next step was to cross the ground data with the 6 indices stack. And doing that, I obtained a table where, for that table, each row corresponds to each point of ground data, and the columns of the table are the features. And what are the features? The feature as, because I have 6 indices stack, and each index stack has 36 images, the total number of features are 216. Okay, and because I am working with 6 countries, I obtained 4 tables. One, a train and test table for Afghanistan, and a train and test table for Iran and Sudan. Well, the next step was, with the train data, was to select a machine learning algorithm. In my case, after doing different testing, I decided to work with LightGVN. LightGVN is a free and open source algorithm that was developed by Microsoft. And also, I work with an algorithm called HyperOp, that is a Python library for model tuning that is based on Bayesian optimization. So, combining LightGVN and HyperOp, with the train data for Afghanistan and Iran, Sudan, I generate a final machine learning model. I work with Afghanistan and Iran, Sudan in one table. I show the information for Afghanistan and Iran and Sudan. The information are from different years, but because I generated synthetic image for the same 10-day periods independently of the year, I can do that. And when, after training the model, I obtained in the final accuracy of 0.93, and you can see as an example the final maps that I obtained for each country, and you can see that the classification visually, you can see that the model is working very well, differentiating between non-annual crop and annual crop areas. And well, that's all my presentation. Thank you very much.
So thank you, Adrian. Thanks so very much. I guess next one will be Ella. Yeah. So floor is yours.
All right, thank you very much. My name is Stella Ampafo. I'm a PhD student at the Technical University of Munich. I'm working at the intersection of Earth observation and machine learning for crop production estimates. So here I present my submission to the crop mapping challenge. My presentation will be more or less spread around introducing the challenge, which my colleagues have done already, so I could skip this quickly and show the relevant information here. So I'm going to present here my experiment setup, the results obtained using different kinds of strategies and testing different models. In areas where we observed more or less low performances, we tried the use of much deeper models to see if we could enhance their prediction performance. And lastly, some findings and recommendations for future or similar tasks. So here, the only thing I would like to say is there's several large-scale crop mapping products. When you compare this, some research have done this comparison, you see that there's not always agreement, especially in areas where ground truth information is sparse. So also the problem here is across several regions, we have different growing seasons and whatnot. So it's quite difficult to have a one solution that fits all. So on this note, our approach is to have separate models for separate regions. Of course, the introduction has also made it quite clear that For 2 regions, we have 1 year to consider, or 1 year time window to consider, but in another region, the data collection period was much more minimal, although we did not also know the cropping calendar in this region, so we had quite some restriction over there. So our approach is also minimalistic, just like my colleagues have also presented in theirs. And we are also thinking something that could easily be set up on platforms such as Edge Engine. So what we did for these 3 regions, I mean, you can see over here when you look at the training on the holdout sets on this competition, you see that they are more or less within the same area, so we cannot expect too much domain shifts. So with this knowledge, we are quite sure that what we see in the training, we may not see too much variation also in the test set. Our data extraction process uses Edge Engine. What we did is a more or less simple workflow to easily generate arrays of a temporal dimension and a channel dimension for each point in our training data set. We use only Sentinel-2, and we consider the 10 and 20 meter resolutions. And yes, on that note, then we are looking at only bands in the visible near infrared range and also the shortwave infrared range. So again, here in Afghanistan, we had a very strict window, and looking at the Sentinel-2 images in this area, we could only have like 6 time steps as compared to Iran and Sudan, where we have over 50 time steps. What we did in addition to having the spectral bands is to generate additional indices, mainly vegetation condition and water availability indices. And this was more or less leading into our experiment setup. So we look here, we plotted NDVI values over these regions. And again, the reason why we need this kind of models is we cannot always set a threshold to easily differentiate what is a crop and what is not a cropland. So this is why, or this is where machine learning comes into play here. So what we do here is having our Sentinel-2 bands and also the indices in hand. We explore very classical models. So mainly we look at random forest, gradient boosting, we look at support vector and K and N, just to also provide some kind of insights into how well these models compare against each other. And also here, our setup also looks mainly at what happens if we are relying only on the Sentinel-2 bands, what happens if we only look at the vegetation and water indices, and what happens when we have their combination. And here I show briefly our results. So our setup is more or less keeping like a 5-fold cross-validation strategy. Overall, we can see here that the lowest performance was associated with Afghanistan. Again, this could a good intuition here is the restriction in the time window, and hence we do not have enough temporal information to aid the classification. But yet, I think that we achieved some reasonable accuracy. What I would like to deduce from this slide is, for example, in Afghanistan, when we looked at random forest only on the raw bands, the raw bands here made up about 10 features. We had 15 features for the vegetation indices, and their combination is like 25 features. So we see one thing here. We could already in Afghanistan obtain reasonable accuracy, over 82% using a random forest. But you see what happens again for when you try to enhance with too many features. Sometimes it gets a bit more confusing for the models. This is not a general conclusion, but of course, this is like a major observation we have made. Again, for Iran, for Sudan, we could achieve the same performances with the raw indices or the raw bands or the indices. And of course, random forest here was a good performer across all the models, but also as support vector classifier was also having the same performance more or less. So it was more picking which one was more efficient in the computation. Now we saw that Afghanistan had the lowest performance. What we tried to do here is how we could improve this baseline. So first thing we did was to increase the time step. So although we had April as the only window, when we look at the vegetation and phenology in this area, we see that the crop was not actually only planted in 1st April and harvested at the end of April, but this was just the data collection period. So we made an assumption here. What if we step back a month and we advance a month? What do we get in terms of performance? So by doing this advancements, we end up with 18 compared to 6 initial time steps. But but we could only gain about 2% in accuracy. But of course, we had to keep a quite strict window. So we explored here again the use of deep learning techniques. The reason why we chose this option, of course, is because when you take classical machine learning, let's say random forex, for example, they do not really make the most of the temporal order. Of course, they can give some very good results, but they do not make efficient use of the temporal alignment of phenology to make these insights. So using the random forest baseline only on the raw Sentinel-2 bands, we tried here a baseline for deep learning, a multi-layer perceptron setup, but we also look at some very interesting model which has been proposed for the classification of crops. It's quite robust, not also very heavy. And by doing this setup, again, with our very short time window, we could already improve about 4% in our deep learning setup. And of course, when you look again at LSTM, we could also have more or less a similar performance. But for the sake of having a very cheap solution, we decided to go with the random forest setup. Also, this could easily also be operationalized, for example, in Earth Engine. So we just gave insights here, but this was not our final submission. In the end, we observed that when you have sufficient temporal information, the classical machine learning models are well enough able to map crop and non-crop types. And again, we saw the benefit of this temporal information in the Iran and Sudan regions, where we reach over 95% accuracies, and the reverse for Afghanistan. But when we integrate deep learning in this time restriction window, we could also improve a little bit our performance. Again, we saw a mixed effect when we had to combine the spectral bands and the indices. Sometimes it was improving and sometimes it was really worsening the performance. So it's really not an issue of more features, but relevant features that could provide insight into the performance. So again, our final submission was based on classical ML, but we have insights into increasing the time window and using deep learning techniques. What we intend to explore in the future, for example, when we look at Afghanistan, the time window was short again, but we also saw what looked like tree crops. This is our assumption from satellite imagery. But of course, when you have these things, they have more or less, they have quite a spectral similarity to trees themselves. And in the time window, it was difficult to separate this. So perhaps, in fact, really improving the time window is what could make a difference in this this mixed classification we observe. And again, although the spectral indices really provided the best set of features, we could actually have reduced the dimension of these indices. And I'm sure we could still gain some performance improvement. But again, this is a competition. Sometimes every decimal place counts. So this is not something we had done in this strategy. But another interesting direction would be the use of object-based instead of pixel-based approaches. Of course, the training data that was given was points-based, but in past competitions, we've seen that people are able to map parcel boundaries from Sentinel-2 images. And when you observe the area that this hackathon was used in this hackathon, one could actually see the outline of the parcels. So perhaps this become an interesting direction to use object-based.
30 seconds.
All right, so lastly, recommendation, again, information on the cropping season is very important. It helps one to streamline the data collection process, but also give insights into which part of the calendar is really relevant to do this mapping. And yes, this ends my presentation. Thanks.
Thank you, Stella. Thank you very much. So next presenter then will be Julius.
Very well. Thank you. Okay. Let me put it in presentation mode. Okay, so I'll start. My name is Julius. I'm all the way from Kenya, and I'm a student, a master's degree student in data analytics. And I'm grateful for the opportunity to present today at this final level. So straight, I may jump introduction because again, Pengyu had done it already, but definitely we were classifying croplands, whether there are valid croplands or not. So it was a classification problem. Yeah. So the data was given for 3 countries, Sudan, Iran, and Afghanistan. So you can see I've tried to put them for Sudan, for Iran, and Afghanistan, just some portions. And a close look, when I did a close look on Afghanistan, I had seen that they had or that region, or the region we were given had varying cropland cycles in the month of April. Again, it was only for the month of April, and you can see down here, some lands are very green, others are like bare, like they have already been harvested or something. So, but for the other region, there seems to be quite a harmony in the cycles for the regions. But again, that was for a full year span. So my approach was to try collect 500 more samples for Afghanistan from Google Earth Engine. So I just got the longitude and the latitude, and then added that to my Afghanistan dataset. So in the final end, my Afghanistan samples were 1,000 instead of 500. Yeah. Then for every country, definitely I would pull the bands B1 to B12 from Sentinel-2 from Google Earth Engine. After doing that, I did feature engineering for all the countries. So location-based information, country classification, quartile binning of the bands. Yeah, and then the spectral indices, trying to see the interaction of the band, the soil-related features, the urban-related features. Again, I know that there were cities and urban areas, so just to try to help the model distinguish that those are not croplands. So I felt that urban-related features were important. Water-related features, I also felt that they would play a big role, especially like in a country like Sudan, where irrigation is much done from River Nile. And then the vegetation indices as well. Yeah, and then some other geographical clustering to unveil spatial grouping within the data. So small pre-processing steps were try to see whether there are outliers in the bands, and then try to cap them, and then to label and code the categorical features that were introduced when I did some location-based information. So that is basically the whole thing. Then initially I tried definitely I tried 3 models once again for this challenge. And I tried quite several of them initially. So final data set had 262 features, plus the band, of course. And then accuracy was used to track the performance. So an initial run with the default parameters for each of the 3 models with the default parameters. You can see on average overall, they performed almost the same, but XGBoost and LightGBM seemed to be on top. So because of the many features, the 262, I felt that XGBoost could be slower. I believe it had some slight better performance like LightGBM. But for simplicity, I settled on LightGBM, and I came up with those parameters. So you can see my screenshot there for my code. Yeah, and then I did 15 repeated k-fold on my data set. And just to mention, I did not split. I did not like predict for each country separately. I just applied my model to the whole data set for each of the countries, for all the countries. So my mean cross-validation score on my machine was around 0.87, and the standard deviation of 1% or so. Uploading to the leaderboard, accuracy was 0.913. But when the private leaderboard on Zindi was revealed, the model performed 0.918. So that is basically how my model or my proposed solution performs. So discussions. Expanding the time span to incorporate longer spans never worked for me. So I stuck with the host given time spans. So I just did Iran and Sudan for year 2019, July, all the way to June of 30th of 2020. For the Afghanistan, just stuck with that 1 month of April 2022. Yeah, so engineering features improved my performance. So using only the bands alone, the public score was not so great, was 0.76, and the private was 0.83. Yeah, so you can see without engineering the extra features, only the bands, the model didn't perform so well. So adding more data for Afghanistan, I thought this would really improve my performance, but did that marginally by around 1% from 0.89 to around now 0.9. So mapping croplands in Afghans posed challenges. So the average accuracy was approximately 0.8. So I tried to just check for this one country, and averagely my scores were around 0.81, 0.8, around there. So contrasting with higher accuracies in Iran, 0.95, and Sudan, 0.98. So croplands, again, as I said initially, they exhibited variability, with some farms being bare, and others densely covered with crops for this month of Afghanistan, for this month of April 2022. So I'll stop at that point. So that was my solution.
Thank you, Julius. So we have last presentation now, Mohammed.
Yeah. Hi everyone. Hi everyone. My name is Mohammed, and I'm working as a junior researcher for advanced computing for Earth observation at Euroc Research in Bolzano, Italy. And I will present the solution for the cropland mapping. Okay. I will just go quick introduction or quick overview about the challenge. That's the problem description. The objective it was to use time series satellite data and then using AI and machine learning models to do crop mapping over 3 different areas: Afghanistan, Sudan, and Iran. And here we can see for Afghanistan, we have 500 sampling training and 500 also for testing. And the time interval or the collected data was in April 2022. For Iran, the time span is extended from July 2021 until June 22. And we're using similar 500 training and 500 for testing. And for Sudan, we have similar time interval from July 2019 until June 2020, and we have same number of training and testing samples. And for the dataset, I used the Google Earth Engine to download the datasets using Sentinel-2 data and Sentinel-1 and soil moisture providing from NASA level 4. And for Sentinel-2 data is optical Earth observation data, including different spectral bands, band 1 and 2 until band 12. I downloaded the 12 bands with main monthly values, and also computed more vegetation indices like NDVI and PSI. And to overcome the cloud presence, because Sentinel-2 is suffering from the clouds contamination. So I added Sentinel-1 data because its ability to penetrate through the clouds. And I used the 2 polarization bands, VV and VH, and adding more features related to SAR, like radar vegetation index. And also I used the soil moisture products, including information about the soil in the different level, like the topsoil layer and the root zone, and other information like evapotranspiration and leaf area index. And here we can just see the time series for the 3 area. And here we can see for Afghanistan, we just use the data is just collected from April, just 1 month. So I added the previous 3 months to expand the time series and try to capture the signal from the different satellites sources. but it's still not enough for the just 4 months. We can still, that's the signal is not clear enough compared to the other regions or countries like Iran. We can see here it's the long time series because it's 1 year. So we can see that the signal is more clearer or capture more information. And similar to Sudan as well. And for the methodology, here I try to do comparative analysis between ensemble tree-based model and the time series model. So the first I restructure the data into 2D data sets to use it for to the ensemble tree-based models using LGBM and CatBoost, and then reconstructure them into 3D data sets to have samples, features, and times. And then I choose the inception time model to be our the reference model for the time series models. And here we're going to the results. We can see here for Afghanistan, when you're using individual LGBM and CatBoost, it's giving me more similar results with just slight difference between both of them, 8.6 for LGBM and 0.85 for the CatBoost. And when ensembling them, we have almost similar results. But was surprising that inception time model, when using 3 data model, it gives worse results with 0.61. And this the similar situation for Sudan, even if you have longer time series, which expected that the inception time model 2 performs better, but that it didn't. And still the tree-based model performs much better than inception time model. And we can see here the ensembling, the 2 tree-based model gave us 0.97, and the inception time model gave 0.61. And similar for Iran, it was the ensemble tree-based model gave better results with 0.96, and the inception time model gave 0.59. And here for the feature importance for Afghanistan to see how the model, which are the most important features. We can see for Afghanistan that's the data are related to SAR data or Sentinel-1 data. Are more important because the data collected in winter. So the ability of Sentinel-1 to penetrate through the clouds, that's made it more important because the optical data, there are presence of the cloud, so they're limited their ability to distinguish between crop or non-crop. In contrast for Sudan, we can see that's because we have longer time series and we have data from the summer. We can see that's optical data from Sentinel-2 data are more important. And we can see here we have data from June, July, and they are really giving higher importance than Sentinel-1 because they're less contamination of clouds. And similar for Iran, but there are here also soil moisture products here have more importance as well, like features related to evapotranspiration, leaf area index. Maybe that's because of the nature of the soil in this region. As a conclusion, tree-based model with tabular data is outperformed the time series model using 3D data. And when you use longer time series interval, that's significantly improved the Cropland mapping accuracy, which means that there is a positive correlation between the length of the history of the data and the quality of the model. And the results also showing that Sentinel-1 data is really important for cropland mapping, especially in winter when there are presence of the clouds. And thank you.
Thank you very much. Thank you very much, Mohammed. So now I guess we comes to the point, yeah, where we have to announce the final ranking. But yeah, maybe a couple of words before, since really we were really impressed about the level of this competition, the participant, the top 5, but not just them, also the top 10 that we had the preliminary presentation last week. And so they were very close in terms of accuracy, and their accuracy was very high, I have to say. I've seen people justifying about the 80% for Afghanistan, but the challenge of having the Cropland in just that month in Afghanistan, I mean, was very hard. And yeah, and you know, they were trying to find explanation for just an 80%. So no, they were, we had very good participants, and now it's painful to say that one was better than the other, but okay, we have to do that. We did based on the accuracy score and also the timing of the presentation, the novelty of the approach, the report that they delivered. But yeah, really, I want to praise everyone. You were, you know, yeah, really congratulations to everyone. It was very difficult to rank you guys. I think Pengyu agrees with me.
Yeah, I quite agree with Lorenzo. All the participants have a very good performance with high accuracies and good technical reports and good presentations. So congratulations to all the participants in this challenge. Andrea?
Yeah, I thank you very much. So I think that maybe you can now announce the winners. You can start with the 5th place, and then I will show the reward, the certificate, and then we will of course get in touch with you to deliver also the money prize that is not negligible even, and I want to thank you, UNODC, for your contribution, which was very much appreciated for sure.
So fifth place is Antoine. Then
Great.
Wait.
Okay.
Wait, that I need to show the certificate for Antoine. Let me wrap up his swapping. Okay, Antoine,
Thanks.
congratulations.
Then we have in 4th position Adrian.
Yeah, congratulations.
3rd, Stella.
Congratulations, Stella.
Sorry, may I say that I'm happy to see that there is also a girl here in this competition, because unfortunately it's not so easy to find ladies in this competition. So, Stella, my special congratulations to you.
Thank you very much.
And then 2nd, Julius. Congratulations, Julius.
Thank you very much.
And the winner is Mohammed. Congratulations, Mohammed.
Thank you. Thanks.
So this brings up to the last part of this event, in which we would make up an outlook of the competition and discussing maybe some ideas for next year competition. But I would like to ask for all the participants to switch on the camera, such that we can see each other, and then it's a discussion, because we will. I'd like to ask you first if you have any feedback, if you have enjoyed the competition, what we can do to improve it. Would you participate in future edition? Any suggestion or thought that you may have?
Okay, maybe I can start. This is one of my first competition on Zindi. I did one before, but in a very short time span. And I really loved doing this competition. If there is maybe one feedback I have is with regard to what was really expected, especially with like the difference between what was expected with Afghanistan and the other one. I think it was more clear for me what was expected when we did actually the first presentation, and it was maybe not as clear in the Zindi description. But apart from that, I loved participating. Yeah.
Yes, you are absolutely right, and we will do future edition. Absolutely. And congratulations again, and thanks for your feedback.
So to better understand, Antoine, your suggestion is to add also a short video where we present better the challenge.
Not necessarily a video, but for example, and other information, for example, the fact, or maybe it was given in the description and I just went past through it, but the fact that the labeled data was done with high resolution images, I didn't catch that. So maybe that's on me. Maybe it wasn't clear enough. I'm not sure, but yeah, things like that are, yeah.
What about the other participants? Did you had the same problem?
I remember there were a lot of chat I had to answer on Zindi about, yes, this time for Afghanistan that was slightly different from the other. So yes, indeed, maybe it's from like our side, my side, I should have make it clearer from the beginning. But yeah, that was also the first time for us. So I mean, everyone is catching up, let's say. So yeah, the good feedback, I guess.
Yeah, I would like to thank you again for this interesting challenge. For me, it was really great that you not just evaluating on the score, because there are many competition just evaluating on the score, which is not a perfect way. So I hope you'll keep in this direction. You have two evaluation, the score and scientific approach as well, which is really great. And one feedback or something for the challenging for the future, maybe because now in this challenge we have data from different time or different location. And if you can make it like how to exploit the models, how we can transfer the model from different place to different place, like spatial validation, how to exploit the time and predict in different year. So it will make more scientific work for people as well, not just, yeah.
Thank you. Good suggestions. Yes.
Maybe last thing I would add, for me, it was quite interesting that all my colleagues also were seeking very simple solutions. Of course, AI is advancing massively, but we should also not forget that sometimes the classical approaches are very competitive to this advancement. So it's always better to start simple and see what the benefits are from there. And another request here again, I iterate the need for the Cropland calendar information. I think this is very useful. Again, in the case of Afghanistan, we have a window for collecting the data, but is this really the cropping season? This was something that I was battling a lot with, but overall, it was a nice experience.
Maybe as we conclude, I would also want to say that I enjoyed the competition. Lorenzo said there was a lot of questions on the discussion forums, and I was one of the people who was questioning a lot to understand the timeline for Afghanistan. This is my second competition using on this GeoAI, and I have enjoyed it a lot. The first one we did with Masauda, the top, congratulations, Masauda. We did the first competition with him back the beginning of the year. So this one was a great one. I learned a lot. I went alone this time around, and I've learned a lot, and I'm looking forward for next year. Thank you so much.
Thank you very much for your feedback. Any other feedback from the participants? And if no feedback, I would like now to ask our hosts, like Lorenzo, Pelliu, and also Maria as a host from the UNGIS. If you were happy with the competition, with the solutions and the report that you have received, if you have planned for next year, if you have some ideas that we can start outlining here, and then of course refine and how we can improve all together.
Okay, so I can start in general. I have to say that, in my opinion, also the added value of these competitions is to provide solutions to true problems. So have in mind that there is also an added value for UN because the both FAO and UNODC will reuse or will partially reuse what you are doing. So it's not simply a competition for awarding young, talented people like you are, because I was really impressed by the goodness of your solution. But really, this initiative is, as you see, is AI for good. So what we want to do is to find the best solution for sustainable development goals. So there is also a value behind it, behind the competition and so on. The other point that I want to underline is that in principle, you can also propose competitions for next year. So we are very open with respect to that. So if you have good training data, if you want to help in preparing competition yourself, so proposing competition to other people for next year, please feel free of do that, of contacting us, and we will do that willingly.
Thank you very much, Maria, for this very nice feedback and suggestion.
Yeah, thank Maria got a very good point, because actually, yes, another let's say benefit of this solution is that they're really applicable to the real time, to the daily work, and we tested here all the solution. We ran it again here. It was possible to run with open platforms like Earth Engine, for instance, and that of course is an added value and something that we can is really usable. So indeed, we will think about maybe more. Also, my colleagues that participate in the previous presentation, the preliminary one, were really impressed. So we want really to maybe give a bit of continuity next year. Maybe it will be the same Cropland. Let's see how to shape it better, maybe. Or we also have other ideas. Challenge with the UNODC that sometimes the data they're not that open that we can share. So we need to really think about it. But yeah, it was really interesting, and it was my first time, and thank you for bringing me into this.
Excellent. Thank you very much, Lorenzo, for your feedback.
Okay. I think I can also add something, and I think both Maria and Lorenzo have a good point as the topic of open GIS is to everything open. So in this year's challenge, we have really have everything open, and all the participants have uploaded their scripts, and it is open. It will be open available to public. And as the topic for the plan for the next year, from our side, that the agricultural application of satellite data site is not only focused on mapping. It also have another side is quantitative remote sensing applications. So currently we have planning to actually have something for crop calendar that is using the time series data to identify the land surface phenology, and in that way it can really do something to the crop calendar. We can use the satellite data-based land surface phenology data to calculate some very important crop stage or crop group stages. In that phase, it will more than together with the cropland extent, the crop calendar and crop stage will also have very good applications in the actual agricultural use. So we are now focused on collecting data and contacting collaborators for the next year's challenge. That's it. Thank you.
Thank you very much. It seems like we will have some very good material for new and interesting competitions in the future as well. If there are no other comments on this, I would like to move to another issue. We are very pleased to announce that we launched the call for papers for a special issue on geospatial AI to advance the United Nations Sustainable Development Goal in the ITU Journal on Future and Evolving Technology. I'd like just to share the screen. I'd like to mention that, of course, Maria is our leading guest editor, so I will ask her to introduce these special issues where all of you could submit a paper for publication. Maria, please.
Yes, yeah, thank you, Andrea. Yeah, just a few words again also on that. So there is this special issue of the ITU, which is related to GeoAI. And so the point is that this journal is not yet indexed, but the advantage is that it has a lot of visibility. And therefore, it could be, in any case, of value of thinking of publishing something. But I was thinking, this is just an idea for you. As now you have all your solution with respect to this specific challenge. One possibility can be that you decided to work all together, possibly also with Pendu and Lorenzo, in such a way of presenting better the problem of the challenge, collecting all the material that you already have. So the research question and also the solutions that you proposed, and putting everything together in the best way, preparing a paper that can be submitted to this special issue in such a way also of documenting what you did all together. So it's the journal is free of charge, so no money needed for publishing, but in any case, it is reviewed. So the papers are reviewed, and therefore also from the scientific point of view is a good experience. And in my opinion, this is very valuable also for documenting what you did, the different solutions that you are proposing. This is just a message for you. If you want to use this opportunity, Your contributions are very welcome. Also, your contribution putting all together. So this is just an option that you can consider.
Thank you very much, Maria. And at this point, I think that if you don't have, if you don't want to add any additional remark, I think that we can get ready for closing the session. So I really would like to thanks all the participants, to you 5 competitors which have been awarded, but also to the other 73 who have actively engaged in the competition. I want to thank again the host of the competition, FAO and UNDC, the UN of the GS Network, Maria, Wendy, thank you, and Lorenzo. And I wish also to remind you that this session, as well as all other sessions we are holding, are recorded, so you can access them in the neural network to which you're connected right now, and also on YouTube. I think that we have been recording now under Maria leadership of this also discovery channel, an impressive number of hours of educational material on GeoAI on very different topics. And then I would like also to mention that we are doing this effort, this work of building up this body of knowledge on GeoAI. And maybe, Maria, you want also to mention, to say a few words on these ongoing activities and all of the working groups.
Yes, so thank you, Andrea. Again, yeah, this can be of interest also of some of you. So one of the points as educator, because I'm professor of GIS at the Politecnico di Milano, one main problem of us as educators is to prepare good courses in GeoAI, because this is something emerging. So it is difficult for us. So you can understand that also professors sometimes have problems, and not only students. So it is really difficult to prepare good courses, taking into account that all these topics are evolving so quickly. So we decided to share our efforts and to start working together in a collaborative way, a group of professors at the international level from all over the world, thinking about syllabi that we can propose for GeoAI and start collecting the main concepts, so start collecting what is called the body of knowledge with respect to GeoAI, in such a way to be able to provide also to our students something that is enough good, timely, and so on. So we have 4 working groups working on this effort. One is for developing syllabus for developers of GeoAI, one for appliers of GeoAI, and one also for decision makers. The last work group is a working group preparing the body of knowledge. You are students, PhD students, I understood, but it could be that sooner or later you will be also a professor. So if you want to contribute also to this working group, we are very happy of having also your point of view as PhD students or young researcher. And therefore, if you are interested, please contact me, and we will put, I mean Andrea and I, because it's always Andrea and I, we'll put you in contact with these working groups if you want to collaborate to this collaborative effort. And so please, if you want to do something related to that, contact us, and you are very welcome. And but now, before closing, Andrea, I want to thank also Julian,
Yes.
because Julian is really the wizard behind that. He's helping in all these events. So thank you so much also to Julian. And again, congratulations to all of you. I wish I had you as my PhD students, because you are really, really excellent, excellent researcher, excellent students. And so good luck for your PhD, good luck for your activity, and be proud of how excellent you are.
Thank you very much, Maria, for these very nice closing remarks. And I thank again all of you. And I wish everyone a nice continuation of the day. Bye.
Thank you.
Bye.
Thank you.
Bye-bye.
Thanks.
Bye, bye.
Bye-bye. Thank you.
Thank you again.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.